Okay, well, I'm glad you've made it to part 2. Now we're getting on to the written questions. It's a little more difficult because you need to draw your own triangle. But if you take your time, you should be fine. This first one, a mine shaft 100 meters long is dug at an angle of 20.6 degrees to the vertical. So I had to think about that, okay, but what that means is I'm digging a mine shaft and miners are working really hard. I know it's not a very straight line, and that's going to be 100 meters long, and we're going to have 20.6 degrees. Sorry about my terrible drawing. And so then that makes a triangle, right angle triangle even. And in meters, how far down will the end of the shaft be? So I need to work out this distance here. Okay, seems reasonable enough. So what information do I have? Well, opposite the right angle, I have the hypotenuse. And if I look at the angle of interest, I have the adjacent. So my adjacent is x, my hypotenuse is 100, and hopefully for my Sohcahtoa, S-O-H-C-A-H, we can see that we're going to use cosine. So cos 20.6 degrees is adjacent over hypotenuse, which is, where am I? X over 100. And as we've discussed before, I want to get rid of that 100 over the other side to leave x by itself. It'll be a little bit tricky and write it with the x first. So if you don't get that, you can always ask or have a look. But when that 100 comes across, x is left by itself, and we have 100 cos 20. Whoa. 20.6, getting ahead of myself. If I put that in on the calculator, I should get 93.61 meters. And you've been told that it's in meters, so please try and remember the units. Okay, here we are with our next question, and we have a tree. Draw my tree. If you read the question, we have an angle of elevation of 24 degrees from a point on the ground. So that means that somewhere over here I am making an angle of 24 degrees, and if you read the question, I am 22 meters away from the base of that tree, which I'm assuming is at right angles. So if I want to label my sides, I better put my x in first. The height of the tree is the unknown, and then I can label my sides. So that would be the opposite side, and this one over here would be the adjacent. So I have opposite equals x, adjacent equals 22, and from my Sohcahtoa, I hope we will use tan, it's opposite over adjacent. If I do this, tan 24 degrees, it's opposite over adjacent is x over 22. This is nice because the unknown's on the top line. And again, I'm just going to bring that 22 across, and hopefully that will leave me with x is 22 tan 24, and I've actually prepared this one earlier, and that gives me 9.80 units. It's in meters. Alright, here we are again. This time Omar has climbed a tree. So Omar's at the top of this tree, which is 10.2 meters high, and his dog runs away at 6 meters per second. My goodness, how am I going to work that out? Well, let's see, he's running along here and he's going for 1 second, 2 seconds, 3 seconds at 6 meters per second. So 6, 6, 6. So that is 18 meters from the base. Now, of course, you could have just done 3 times 6 equals 18. I wanted to include that for an explanation. Then you need to find the angle of depression. So I'm going to draw that in and try and do a good job of that. I've got a right angle triangle, which is pretty sweet. But what you probably remember is the angle of depression is the angle when you look down. So if I call that theta, and a little tip that I was giving people in class is that means that this angle down here is also theta, okay, because the base and that top line are parallel, and so those angles are the same, and then I can label and get on with the job. So using that theta, I have an opposite side and an adjacent side. So opposite is 10.2, adjacent is 18 meters, of course. So I'm going to guess tan. It's opposite over adjacent. So tan theta equals opposite over adjacent, which equals 10.2 over 18. Now use my anti-tan. Theta equals tan inverse of 10.2 over 18, which hopefully is 29.54 degrees. And we're done.